this video, we'll take a look at an example of a data science project running on a cluster versus the efficiencies of running on the scalable single system image of a Lucata system. Each block in this diagram represents a conventional server in a cluster. First, data scientists import data from a heterogeneous set of data sources for cleansing. Next, they create a pipeline of data processing algorithms connected in a series, where the output of one algorithm is the input into the next one. The current approach is to reduce the amount of data analyzed at each step to a size that fits in the memory of a single blade server. The output is stored in temporary files or in a computation graph to be shared with the server in the cluster assigned to the next step in the process. Significant data movement and network bandwidth consumption is inevitable. In a cluster, this data movement happens at each critical stage of the process. The process is highly inefficient for the data scientist, who spends 80% of their time cleansing data and preparing pipeline flows. It also results in waste of the computer and network resources. This fast data approach has another drawback, in that reducing a large problem into a smaller dataset doesn't always give a great result. Rather, it's done for efficiency based on the limitations of conventional computer architectures. With Lucata, there's no need to perform this iterative data movement. Instead of worrying about dividing data across many independent memories, each an independent system in a cluster, Lucata offers the ease of a truly scalable shared memory system against which criteria can be applied without data movement and without data reduction. The 3D grid represents our scalable modular system where each vertex is a node in a single system and where all memory is a single shared pool. The highlighted vertices reflect calculations occurring on data across the shared memory system. It's the algorithm that moves to the data. Data is still imported into the system and cleansed, but not arbitrarily reduced, delivering a result with potentially less skew. Data movement is significantly decreased in the modeling stage, as each algorithm can be applied in place and intermediate result files aren't created or sent over the network. This process of streamlining opens up more time for the data scientist to explore insights from a range of algorithms. Thank you for taking a brief look at how Lucata's technology converges compute and memory architectures to solve the next wave of big data, artificial intelligence, machine learning, and application problems. To learn more about our innovative, scalable technology and how it can help solve your big data analytics problems, visit lucata.com.